stream to it. I've been doing a bad job at that, so pressing the go live button, and it's finally working. There we go. Um, and last time I actually didn't realize, but I wasn't getting linked in chat to the chat aggregating tool. So I'm going to be watching the comments as well. And hopefully I don't mess that up. So let's see. Today's conversation is going to be about math and programming. And I thought this was a super cool topic. Maybe some people don't, I guess. But I think it's a cool topic because a lot of people hyper focus on math when it comes to programming. And I think one of the challenges is that, especially for very new programmers and new software developers, right? They they see it as a barrier, right? They say I end up not knowing math, therefore like I can't ever program. Like it becomes like a self-sabotage type of thing. And I wanted to be able to talk about this more broadly. Just checking the chat. Hey James, good morning to you. It's actually quite the opposite here in in Seattle area. It's 9:30 in the evening, but it's really cool. There's people from all over the world that join this, and it's awesome to have people that can do that. I want to I want to kind of, frame this conversation, right? The idea that I wrote about in my newsletter this past weekend was that, like, how much math do you need for programming? And I had an interesting way to do this. I decided I was going to take to Twitter, because Twitter is a source of knowledge, right? There's lots of people on Twitter with lots of opinions, and whether or not the opinions are, right or wrong, there are opinions to be shared. So I thought it was going to be really cool to hear from different people about what they thought about this. So if you're not following me on Twitter, it's just Dev Leader on Twitter, or X, whatever you would like to refer to it as. And the question that I posed was, people seem hesitant to learn programming because of math. This is kind of what I said right when I started the stream, right? So how much math do you regularly do in your coding? And it was framed this way because I wanted to make sure I could have a bunch of different opinions and have people kind of discuss this, because I do think that uh, there are different ways that you can look at this and try to answer this. But the point, the point of this question is that I wanted to kind of collect data points, do a little bit of social media research, if you will, from different people in the industry, or maybe they're trying to get into the industry, right? People that program or want to program, and their thoughts about math. So there's a bit of bias when I do this, right? Because I'm kind of seeing if I can prove a point, but I don't control the responses, right? So that's the thing. If everyone jumped onto the Twitter thread and said, I do calculus every day at work, then here I'd be kind of saying, oops, I guess maybe my hypothesis was wrong. So the way that I framed my article was in response to what this tweet was. And this, I don't know, I'm not very big on Twitter or anything like that, but this tweet was the most, I guess you could call it, like, successful tweet that I've ever had, in terms of, people engaging with it, and having really interesting conversations on it. So um, I thought that it would be cool to kind of break it into three different categories based on the responses. So uh, it's not like it was, completely one-sided where everyone just said no math, or only math. There's kind of three different ways. And the categories of things are that people said they do math every day. There's people that say they never do math. And then there's this third category where people kind of, I don't want to say they're trolling, but I think they're kind of trying to pick apart the statement. And instead of just answering like, yes, I do math, like in programming, or no, I don't, they try to frame it like programming is math, right? There is no separation, or it can be represented mathematically. And I want to talk about all three of these things. Just checking chat. Hey Nick, I'm a .NET dev and I've been writing .NET since 2021 at my job. I've been writing it for 3 years. Still not confident in my skill set and understanding it. Learning through a book, but it seems I can't stretch examples from the book to solidify learning. Um, I would, my recommendation for anyone learning programming is, of course, you're going to want to get exposed to, um, different concepts in the language. Like, the recommendation I have is, hey, go build stuff. But if you've never seen the code before and you're like, well, how do I even code something if I don't even know what the language is or what language to pick? In your case, at least you've kind of started looking at .NET. I'm assuming C sharp here. And if you're checking out books and stuff, that's great. But I think once you see some of the language features, I would highly recommend setting a goal for yourself and try to go build some things. And they can be extremely simple. I think people get this very confused that when it's like, hey, like, the recommendation is go build some software to get better at it. People go, well, I don't have any business ideas. Like, well, I can't go build the next, Netflix. And it's like, well, that's not what I'm saying to do. And I think we have to be a little bit more guided with this kind of advice. You could go build a console application that is a calculator, right? Like, you have to start extremely simple so that you can start practicing, and from there, you can keep expanding on the example. So, I won't go off the rails for this conversation yet. I'll have more time at the end of this for more, questions and stuff. Obviously, I don't want you to not ask them, but, if you are just wanna get a head start, if you check out my website, so devleader.ca, if you just search for projects, I have a few articles that explain some of this, and even on my YouTube channel, I see you're on YouTube. If you just search projects on my channel, there's a couple of examples for doing that. But otherwise, I can try to help more offline if you want to send me a message on a different platform, and I can try to guide you there. Okay, so for math and programming, I wanted to kind of start with the I do math every day because I thought this was super interesting. And if you haven't guessed already, I find it interesting because I take one side of this, you know, uh, a significant amount. Like, I don't do math every day in programming. So some people that were commenting on the thread were saying like, I do math every day. Every day is math for me. I've been doing math for years in programming, and I saw a handful of these coming in, and there wasn't a lot of like explanation. So I'm kind of going, well, what are you building? Like, I've been building software for over 21 years, and I'm like, I don't do a lot of math. So I started asking. I started saying, well, hey, like, that's really interesting. Can you explain more about the types of things you're building? And there's it seems kind of obvious in hindsight, but when people started explaining, there's a lot of themes that were coming up. So there were people that were saying like, well, I write software for financial institutions, right? I do a lot of work with money and finances in the software that I'm building. Okay, like that makes sense that you're going to be doing a lot of math if there's money involved. Okay, I get it. There were some people that were saying like they're working on analytics platforms or data analytics for the company they're working at. And again, like, yeah, that totally makes sense. Like, if that's what you're doing with software, I can imagine that you have to know a whole bunch of math because you're literally doing that for work. And there's two examples, right? But you might start to see the theme already. Other people were saying, hey, like, I'm working on games. So graphics and things like that. There were people that they were doing graphics and didn't even mention games. Don't know if they meant games or they're doing graphics for something else. But the point is that the people that were saying, like, I do math every day were people that were working in domains that required a lot of math, right? It's kind of obvious when you think about it. So I thought that this was really important because when you ask a question like this, like how much math do you do in your coding, of course, there's going to be people that work in a field or a domain that requires math. And in one of the last live streams I did, I kind of started off the conversation by talking about bias. If these people work in areas that require a lot of math, given the domain they're in, like, if a new programmer was like, "Hey, I want to learn programming. Like, do I need to know math?" These people might have a bias, a strong bias that says, like, "Yeah, like, I do programming every day. I need to know a lot of math." I'm not saying that every one of them is not going to recognize, this difference here, but there's an opportunity for bias. And even if a person that was new to programming was asking this more generally, they might not almost be asking the right question. It's the question should not have been, do you use math in your day-to-day work? Because the reality is these people absolutely do. The question is really more, and this is kind of the hidden part to it. The question is really more about, do you need strong math skills to become a programmer? Right? That's my hidden question that I did not put in front of people's faces. Okay, so I started talking about this as a bit of a theme, and the theme for this part was really for folks that are doing math every day in their programming. It's it seemed to be that it's not because the programming itself, like how to code, required strong math skills. It's that the domain that they were in was literally something that was based within math. And I think that's actually important to kind of call out, right? So not only because I think it helps support some of my perspective a little bit, but it also can do the opposite. And when people ask me like, "Hey, I want to learn how to program, but I don't know math." If someone wanted to be a game engine programmer and they left out that detail, and I'm sitting here going, "Oh, you don't really need strong math skills to become a programmer." Like, yeah, you do if you want to be a game engine developer. So I think that there's extra context that really helps steer this question. So the way that I look at, this set of answers was really math it was not a fundamental requirement, like strong math skills was not a fundamental requirement to be a programmer, but there are absolutely different domains or industries, different fields where math is absolutely going to be exercised. And the type of math you're doing will depend heavily on the field. So I think that's important, especially for new people to understand. I kind of wanted to address that. Okay. Now I want to talk about the other one that was kind of interesting. And it was the group of people that was, again, I don't know if it was like trolling on Twitter or if it was more about like philosophically they disagree with the question. I think there was some of that. Um, but the group of people that was essentially saying things like, I think that, and there's a handful of different ways that this came up, but things like um, programming is math. So to say that you don't need math to program doesn't make sense. If programming is math, then you need math to program. Okay, I can see the logic there. There were people that were kind of indicating like, basically everything can be represented by math. And I mean, yeah, I guess given whatever complex system we have in existence, you could given enough time, you could probably find mathematics to model it. Sure, you could make like a philosophical argument like that, but it's weird. Like it's not getting to my hidden question, which was, do you need strong math skills to be able to get into programming? Right. So of course, if I don't ask that explicitly, people are going to come up with creative answers for this type of question, which I think is fair. Um, and uh, I think what was interesting about this was that like there's a really good point being made here. And even if I like don't want to admit it because it's not siding with my narrative, I think it's really important to talk about it. And these people are right by saying like programming concepts can be modeled by mathematics. Right, and I see, like, on Twitter, like, on the chat here, I consider programming as more logic than math, and I'm gonna dive into this a little bit, right? And I actually had a really good exchange with someone on LinkedIn, actually someone that I really admire, his name's Eric, um, so I'll kinda dive into this, I guess, because it's a good segue. I had posted about this live stream, and I said, "I wanna talk about, math and programming." And his perspective was literally the exact opposite of mine, and he said, "I think a lot of people." And sorry if I don't, I'm gonna paraphrase this, it's not a direct quote, so I hope I don't misrepresent the intention here, but, um, Eric was saying along the lines that he thinks that math is a requirement for programming, and basically said, like, all programming is basically discrete math. And if you go like Google search, like what topics are in discrete math? And I did this because I was thinking back to university. I was like, man, I I used to like do quite well in school, and when I entered university and I had discrete math classes, that's the first time in my entire life where I was like, I'm failing courses. And this was discrete math. And if you look up the topics in discrete math, it's basically like all sorts of programming concepts. And in part of Eric's, argument, he went on to say a couple of things like um, abstract, like math is abstract thinking, math is logic, um, and like I fully agree, right? And then went on to say like discrete math is used like basically every single day in programming, which I mean it's true. So, and I apologize on Twitter. I can't pronounce your name, so I will not try because I think I might embarrass myself, and I don't mean to insult you by trying. But I consider programming is more logic than math, and I agree with this. And my response to Eric was essentially this: like I 100% agree that math, um, is something that requires abstract thinking and that it builds on logic and how you think logically through things like algorithmic thinking. Like absolutely. But I said that these are skills that if you practice mathematics, these skills will improve. And similarly, if you practice programming, these skills will improve. These are separate skills, separate from, explicitly being mathematics that are very beneficial for programming. So my sort of counter argument to him was like, I don't think you need to get good at math in order to exercise those skills. And if you can find a different way to exercise those skills, you can leverage those skills for being a better programmer. And when I think about some of the other response I had to him is kind of like what I just hinted at with like how I did very poorly in mathematics in university. It took me like my program was 5 years, but it took me in my fifth year, like or whenever the last set of math courses I had, it took me my entire university career to go from having 50s in math to finally getting back up to like 80s. And like that was very difficult for me because I had like I've said this on stream before, but in like high school, I never had to try at anything. I just had good marks and I thought I could coast through university. That was absolutely not the case for math. And the whole time I'm programming, I'm doing excellent in programming. It's always, I'm not trying to be cocky. It's just something that I've always been kind of aligned with and I've done well with it. But the difference was, so I think from Eric's perspective, he's saying these topics, things like trees and other different types of algorithms, like these are mathematical topics. They can be represented in math. And I think that is 100% correct. But I can tell you for a fact that I didn't go look at the mathematical proofs of the different algorithms for things like trees and anything else that's in discrete math. And I went, oh, now it makes sense for programming. 100% the opposite. You could tell me any of the mathematical proof stuff, make me practice that, and it never for a second made any sense in programming. But as soon as you put me in front of a computer and said, like, we're going to use this data structure and here's some of the characteristics of it, all of a sudden, like, it starts to make way more sense. So for me, I'm just trying to illustrate that thinking about it from a different direction, a different perspective, made a huge difference in terms of how I could understand it and apply it to programming. But these concepts truly are like they can be mathematically modeled. There's proofs and everything for them, right? So this goes back to I kind of asked the wrong question. And I kind of said back to Eric in my response, and I'm kind of not trying to pick on Eric here. I thought it was a really good comment. But my response back to him was kind of like I my uber point here is do you need to be good at or my goodness, do you need to be good at math to become a programmer? And I still stand by my perspective, which is no. If you are good at math, right? If you're good at math, it likely means that you have good abstract thinking, you have good algorithmic thinking, right? The way that you think logically through things is probably very good. And as a result, that translates well into programming. So can we see the difference there? Like the point is that my statement, my claim is not, hey, there is no math in programming. I'm quite literally acknowledging many, if not all, programming concepts can be modeled through mathematics. My other claim, though, is that you do not need to understand the details of the mathematics in order to be able to program. Now, one other thing that came up, and this one is kind of weird, but like I do agree with it. Someone said, well, if you're doing Boolean logic, that's also mathematics. So, like, try and tell me you're not doing Boolean logic. Okay. Like, you got me there, but I guess the I go back to the theoretical aspects of Boolean logic and thinking through the proofs and stuff. Like, that's not how my brain works when I go to program. So, it's not a mathematical mindset that allows me to go leverage those tools. It's truly like an algorithmic mindset. It's not math. And this is again, this is my opinion, my perspective on it. I'm just kind of sharing this with people. Which is going to bring me, I guess, to this third point. And I do want to make sure I have more time for questions too. So this one is probably a little bit shorter in terms of, the content that I built up to go over. But absolutely more time and stuff for questions if people want. So the third group of people is the group of people that's kind of in the same camp as me, which is I don't do math when I program. And I didn't count the number of responses. I don't know if I can do that easily on Twitter. I have it pulled up here, but I'm not logged in this browser. But there, basically, like, I wish I should have got like a rough number, but there was an overwhelming majority of people saying things like, you know, never 0% of the time I use math. Just like any way that you can try and say I don't know how to do math, and if I had to, I wouldn't be a good programmer. There were so many people taking this perspective, and to me, this is exciting, not because I want to sit here and say, "Hey, look, my perspective's right," because it's not the point. And I don't think that there's one right perspective on this, but I do think that there's a good takeaway from this, and that's that I was able to go onto social media, whether or not you think Twitter's a good spot for it or not. Sorry for people watching this on Twitter, but some people don't like Twitter, right? There's people developing software. There's software engineers on Twitter that responded to this. There were many. There were tons of people that responded to this. I was completely shocked how many people were like, I have a strong opinion about this. And an overwhelming majority of them said that math was not important. It didn't come up in their day-to-day programming. And the reason that this is exciting to me is that I finally have some anecdotes from people in industry to be able to go tell other people, like I mentioned at the beginning of the stream, people that say, I wish I could get into programming, but I'm not good at math. Right? My goal is not to go on Twitter and or any social media platform and just argue with people. Like that gets no one anywhere. I don't care. If you want to look at programming like math, that's totally cool. Like I power to you if that is how you perceive and like can, solve problems and stuff. If it's all looks like math to you, like that's super cool. That's not how my brain works. I don't think that's how a lot of our brains work. So, being able to have a lot of evidence and anecdotes from people to be able to bring to more junior engineers or people that want to get into the industry. And I can finally say, like, it's not just my opinion, right? There are tons of people that also have this mindset. And if they're able to get by being successful in their career saying, I never do math, you should be okay. And I should clarify when I say never do math, I mean, some people said never, but other people were saying like fifth grade math. And when I say never do math, I mean like I count, right? I do lots of counting in my programming. Sometimes I have to add some numbers together and subtract them. The most complex thing is like division. Like I don't, I don't, I don't do complicated math. It's very rare. And when I am doing more complicated math, it's very situational because the domain that I'm working in requires it. That's really it. Like if I need to go write some code that's calculating statistics for stuff, you can bet I'm going online and checking for a formula and then like I don't know it. But again, my point here is that for folks that are trying to get into programming, and I'm kind of encouraging people that are watching this, right? If you have if number one, if you are someone that wants to get into programming and you've been nervous, like, hey, my math skills aren't that good, it's okay. It's totally okay. You need to be able to like to problem solve, think through things logically, and those are skills you can build up without math for sure. But you need those skills. You will have to work on those skills. And for the other folks that are watching this, if you are in industry and whether or not you have an opinion about how much math you do at work or in your projects and stuff, I want you to please keep an open mind for more junior developers or people that are aspiring to be software engineers. If you put the barrier up that says you must be good at math, like what are you actually encouraging them to go do? What like if it's that general, right? Like should they go learn calculus? Should they go study discrete math? Like what are the things they have to be good at? You can't just say good at math, right? So I think putting that barrier up makes it like I don't want it's a little bit like gatekeeping, I guess, even if it's not intentional. I think people have enough challenges to overcome anyway to get into software engineering. And the last thing they need is like more self doubt about their skills. They can absolutely work on problem solving skills, algorithmic thinking, all those things. I'm not saying they're going to love it. That's a different story. People very well might find out they don't like software engineering. That's okay. But you don't need advanced calculus. I couldn't tell you how to do a derivative or an integration or integral anymore. You know how to do Laplace and Fourier transforms. I could not tell you how to do that. I can't multiply matrices or none of that. Nothing I learned in universities are things that I apply now. Like nothing. Not saying it wasn't useful because I think it helped me with my algorithmic thinking, sure. But I don't know any of that math anymore. And I don't use anything like that in my programming. So I think that was my spiel. That's what I wanted to go over today. So I do want to open up for more questions. I know there was a question towards the beginning of this about projects for developers. If you're still on, I can't see who's actually still like in the chat and stuff. I can see if you're talking. But if you're still on and you want to talk through projects, we can do that now. I'm happy to take other questions. I should probably do a little bit of a plug for courses. And sorry, I'm not trying to make an advertisement for this. A little bit, I guess, but there is a big sale, and it's not even my sale. I don't control these, but it ends on April 30th. It's for Dome Train's birthday, so I'm just going to try to switch my screen here. Um, so I have courses on Dome Train, but this isn't my website, right? This is just where I have my courses. Nick Tapsis, who runs Dome Train, has put on for Dome Train's birthday, there's these discount codes, birthday 40 and birthday 20. So, yes, I'm plugging this, but I mean, if you don't want my courses, there's lots of awesome courses here. They're all discounted. It does end on April 30th. It's a legit coincidence that I'm trying to do a live stream. I do them on Mondays. April 30th happens to be tomorrow. So, I mean, it's going to end, but there's lots of awesome courses here. This is the Black Friday pricing. So this kind of thing won't pop up until the end of the year, but lots of awesome courses there. Okay. That's my spiel for plugging courses and ads and stuff like that. I don't like doing it, but I think I truly think that there's some helpful stuff there. Okay. I'm gonna be watching the chat for questions. I'm gonna circle back to the project one in case there's some more interest around that. But when it comes to building projects, and I guess maybe I should back up. The question was really about like, how to position oneself better for learning versus just reading stuff. Because if you're reading books, how do you start applying it? Like sometimes it's not really sticking. If I back up for this question, this is like kind of referred to like tutorial hell. And the reason that it's called this is because I think a lot of the time we associate learning with just like collecting information, if I can call it that way, right? And it's not that there's something wrong with reading books. I'm certainly not saying that, but it's the same argument. Like replace book with blog articles, right? I write lots of blog articles. And you could replace blog articles in that situation with YouTube videos. They make lots of YouTube videos as well. I don't think that the best way to actually learn something is to binge reading books, reading articles, and watching YouTube videos. I make two of those things very regularly, and I'm telling you that's not the best way to learn. I think that those are supplementary things. So, the way that I would recommend approaching this kind of thing for improving your learning, if you're kind of starting off, trying to kind of level up in your learning, and you're feeling stuck, is I think you need to flip things around. And it sounds kind of weird, but hear me out for a second. When you're doing things like tutorials, right, or you're reading books, watching YouTube videos, you get this you get this kind of feeling, this feedback loop, like I'm doing the thing that I need to do to be able to learn. That's great. Like I think it's great that you're taking those steps to be able to learn. But what's happening is that those things are not being applied, unfortunately. Right. So there's two parts to it. One is going to be collecting the information, and the other part is going to be applying the things that you're learning. Because if you're not applying them, those concepts will not stick. I know this is going to sound like a huge tangent, but it's the same reason I was saying, like a little bit before, I talked about being able to do like Laplace and Fourier transforms in university for math. I can't do those things anymore. I could only do them briefly because I was practicing them. I don't have that skill set anymore, not a chance. And with programming, it's similar. You cannot just expect to read something or watch something and go, "Oh, now I can do it." Right? I'll give you a different example that seems like it's ridiculous, but it's the same concept. Okay? Here we go. So, imagine I want to become a better basketball player. This is kind of ironic because I'm very short, so bear with me, but if I wanted to become a better basketball player, what I cannot do is just go watch videos about, how to dribble, how to pass, how to, shoot and get the points. Like you can't just watch videos on it. You can't just read books on it. You have to go practice it, right? Those things could be helpful, right? Like you could go watch video tutorials on those things or read articles or books on how to be better at those skills. Those can be helpful, but you do not become better at it unless you practice it. But back to what I said about flipping things around. I think it's important to be able to supplement your learning with things like books, articles, videos, all that kind of stuff. Like like even courses, right? I don't think courses are a great fit for everyone, but there's some accountability there because when you pay for it, you're like, I want to get something out of this. But even if you just did a course, right? I don't think that that's a solution. I open up all of my courses by saying, I highly recommend that you follow along and code as you're like leveraging my course. I do not just want you to watch it. I want you to be programming. I want you to go pause the video and go program it yourself. So when I say flip things around, what I mean by that is leverage the problems that you're encountering with building things to say, "Oh, I don't know how to do this. I should go watch a tutorial on it. I should go read an article on this. Go read a book on this." acquire the information and go apply it, right? The narrative is completely switched. Instead of saying, I'm going to go consume information and try to find a place to apply it, you change it all around and saying, I'm going to try to build this thing. And when I get stuck and I don't know what to do, I will go leverage some different resources to go see how to solve this. I'm just going to do a quick check on LinkedIn because I don't know if the comments are coming. Maybe no one's watching on LinkedIn. That's okay. I just don't want to. I missed comments last time. I'm gonna feel terrible if I do again. Okay, maybe no one's there. That's okay. So yeah, I think flip things around. Try to build some stuff and see where you get stuck. And then you go, okay, well, Nick, that's cool. That makes sense. But like, what the heck am I supposed to build? Right? I just started programming. How am I supposed to go build anything? And I kind of exaggerated earlier in the stream when I said this, but this comes up a lot where people will say like, I don't have any ideas, like, because I think they're trying to think about it like a business, right? Like, I mean, we all want to be programmers and software developers so we can go build things and eventually make money doing it. But when I say go build stuff, what I don't mean is I hope you have a good business idea and you need to go become an entrepreneur to do it. Not what I mean at all. Um, I've even told people you don't have to finish the thing you're building. Like the point of you building things is to practice, right? So you start building something, you're making progress on it, and there's a goal there, and that's to learn. As soon as you don't feel that you're learning with the project that you're working on, you could either add some scope to it, right? So add some new features, change sort of some of the goals that you're trying to build for, and that introduces new challenges, right? So I gave you an example of a calculator. There should be a simple console application you could go build. And you go, cool, okay, like I can take the user input, I can add the numbers, like I got it. That's pretty simple. Awesome. Okay, go make it a WinForm application, right? It's still a calculator. Go put a user interface on it. Okay, and you go try it. Like now you have to, how do I go make a WinForm application? I'm saying WinForms. Maybe I should have said like WPF or Maui. Like WinForms is maybe dating myself a little bit, but um, you go now you have to go learn about WPF and Maui and you're going to go build some cool desktop application. That's awesome. And now you have that and you go, see, look, Nick, I finished it though. It's still a boring calculator. And I go, cool, make it on mobile now. Right. If you did it in Maui, you could try, putting it on an Android phone or an iPhone, whatever you have. That's cool. Right now you have to go watch some videos and read some articles on how to do that. Great. Okay. Cool. But the whole time you're practicing like you're programming, right? Like you're building more stuff in C sharp. And now at this point you say, okay, Nick, I built a console application that was a calculator. That was super easy. I got that no problem. The WPF stuff, sure. And like I made it into Maui. Now it's on my phone. Cool. And I go, great. Now make an ASP.NET Core application and I want you to make some endpoints that can do adding, subtracting, multiplying, and dividing. It's still a calculator, but now you have to go learn this tech stack, ASP.NET Core, right? So the point is not that you're going to have a sweet calculator at the end. It's a calculator. There's a million calculators, right? There's keyboard shortcuts that open calculators on your computer. The point is not that you have the best calculator in the world at the end of it. The point is that you spent time building things, right? You might not have finished the mobile calculator and you said, this wasn't interesting and I don't like it. Great. You learned something. You learned that you don't like doing that. That's okay, right? You're spending the time building stuff. That's the only way that you're going to get better at it. So go do those things. I had a, if you're watching this on LinkedIn, if you follow me on LinkedIn, then you guaranteed know who John Cricket is. And one of the YouTube interviews that I did with John Cricket, he had really good advice for this. If you don't know who John Cricket is, he has a newsletter called Coding Challenges. And the whole point about it is giving people coding challenges, as you might have guessed, to be able to go practice programming. And he was talking to me about like, I was asking questions about people getting started, and like people often say like, what's the best language? What should I go learn? And his advice was really cool. It was kind of like, try something, right? And see if you like it. And if you like don't, just go try something completely different. And he said the same thing for languages, right? Go build something in Python, see how that feels and like whether you like it. Then try building something in C sharp. Maybe try something in Rust. Like this is the if you don't know what you want, like go try it. Go feel it out and explore it. And the same thing for tech stacks. And when I say tech stacks, I don't mean like I don't want to hyper focus on like, oh, you have to go use a tech stack. I mean like the domain, I guess, or like the form factor. Like you want to build websites, mobile applications, servers, like all that kind of stuff. You might find like for me, I actually spent many like over a decade building like desktop applications. But like I'm not I'm not inclined to go build pretty user interfaces at all. At all. I just had a lot of experience working in WinForms and WPF. So now that I do a lot more web stuff, where do I spend my time? Well, it's certainly not in the front end. That was never something that I enjoyed doing. I just happened to be have a skill set for WinForms. If I could put together user interfaces and someone would say like, "Hey, it's functional. It looks terrible. Can we move stuff around?" And I would say, "No problem. You tell me where you want the stuff and how you want it to look. I'll go do it." But I don't have an eye for that, and like it doesn't really click for me. I don't enjoy it. But I love doing the back end side of stuff. But that took a long time to figure out, right? No one like not a lot of people know this stuff right away. So go try some stuff out. Build projects. It's okay if you don't finish them. No problem, right? Like you spend that time learning. And hey, Maria, I do see LinkedIn chat this time. I don't know what happened last time, so I'm glad that I can see your messages. I made sure to have LinkedIn pulled up so I could watch it, especially to see if comments are rolling in, but it is coming in the chat now, which is great. So I'm happy to see that. I think this tool is telling me that one of the oh, my Twitter broadcast isn't running. Man, it's always something. Um, but yeah, I don't think there was any other questions and stuff that came in, so maybe I can wrap this one up a little sooner. I'll leave a couple seconds if anyone wants to jump in with questions though, but otherwise this might be done, and that's okay. I'm waiting for anything else to roll in. If you're curious about content that's going out this week, blog articles will be about dependency injection, trying to build up towards a bunch of plugin related stuff. I've been kind of teasing at some plugin stuff and finally going to do that. The videos this week will be related to that as well. And so it'll probably be a week or two after this where I start putting out more plugin content that can be applicable for Blazor and ASP.NET Core. And then newsletter topic for this week, I want to talk about not quite job security. It's almost the opposite. It's a bit of a paradox. I want to talk about being irreplaceable at work and sort of the paradox about being irreplaceable, because I think it's a really interesting topic. So that's going to be what the newsletter is this week. So thank you, folks, for watching. I would say if you want to hear more about the newsletter, please check it out. It's at weekly.devleader.ca. And I think most people were probably watching this on YouTube, which is cool. But if you prefer other sites, basically anywhere you can stream, you can find me, except Twitter. Apparently today it looked like it cut out. Because there was a comment that came in from Twitter. I don't know what happened with the broadcast, but it happens. Cool. Okay. Thank you so much. I do appreciate all the support. I will do this again next Monday. And yeah, it likely will be about the newsletter topic. So if you don't read the newsletter, you should. But I'll be talking about that topic on Monday's stream. So thanks again. And I will see you all hopefully next week. Bring a friend.